Hello and welcome to the 7th lesson in Unit 4. Today we're looking at sine functions and their real-world applications. So at the end of this I want you to be able to connect sine functions with real-world situations and be able to use, and we're not using the graphing calculator, we're actually using our Desmos app. So if you have a smartphone, iPad, Chromebook, you can use Desmos, either the app or the website, to help solve problems. So the first question here, we want to make connections with sine functions, and I just have one example that's going to cover all the bases for us. So in the first example, it says the height h in meters of a point on a boat's propeller. So if you're not sure what that looks like, underwater for a boat, we've got the axle, and then there's this kind of clover leaf looking thing here with the propeller blades. So there is what a propeller is looking like, or what it looks like. That's under the water, so here's the water level. And we are looking for what's happened basically. You can think of a red paint spot is on the tip of that propeller, and we are watching it rotate around as it runs. And what we're doing is we're going to assume that the center line is right there, and we're measuring angles. So for example, 30 degrees, 95 degrees, and so on and so forth. So we're measuring how many degrees has it rotated from its original position. So we're just watching that red dot go around in circles. So what they've done is they've come up with an equation to model the red dot. So if we're underwater watching that red dot in slow motion, this equation models how that red dot moves. The T represents rotational angle, so that's the angle I was referring to up here. It's rotated 30 degrees or 95 degrees or whatever, so how far is it rotated from its starting point? And again, h is the height relative to our water level. So part A says provide a sketch of the resulting graph. So this is what you're going to do for me this year. In this particular lesson, what you're going to do is you're going to use Desmos to graph the plot accurately. So I'm going to switch over to Desmos here. So moving into Desmos, what we need to do before you start using Desmos, this is absolutely crucial. You need to hit the wrench up top here, all right, and you need to set it to degrees. So you can see down here, make sure it's in degrees, because if radians is highlighted, it's not going to work. So make sure it's in degree mode. Once you have that, you can now enter in your function, y equals negative 0.012, oops, not 0.012, 0.12. Now we need trig function sine. We use the functions right here. So if you hit functions, we can find our sine. And in the brackets, we had t plus 90. Now Desmos doesn't accept t's. It only works with x's and y's. So we go ahead and we use an x instead, plus the 90. And then outside the bracket, we have minus 0.43. And there we go, it'll plot the graph. I'm now going to make this disappear so I can see the whole graph. Here it is, so I'll swipe up. And there is our graph, all plotted for us. You tap on the graph and you can pick off all the key points, the highs and the lows. Alright, so this is what you're going to use to answer most of your questions. The A part in the question though, if we go back to the note, it's going to say provide a sketch. So what I've done already, I've taken a screenshot and inserted here because I wanted to be able to talk about what's expected when you go to write the homework or the tasks. All I want you to do is I want you to provide a sketch. So what you're going to do is you're going to provide me with a graph that looks like this. So here's my x values, here's my y values. So you're going to be looking at Desmos and you're going to say, okay, my first key point is right here at negative 0.55. So I'm going to put negative 0.55, and I see that it goes up to negative 0.31. So I'll do that, negative 0.31. And then I look at my key times here. So I see 0 seconds, or 0, 180, 360. So that's what I'll plot on the x-axis, 0, 180, 360. And then I can plot my points. So I know it's right there, right there, right there. And that's all I need to see when it says sketch it. So you're just going to give me a rough sketch, because what this allows me to do is to tell whether you entered it into Desmos properly. All right, you don't have to accurately graph it out. I just need a quick sketch. All right, now that's crucial because you need to use Desmos or your sketch then to answer the rest of the questions. So down here it says two things. First thing is determine amplitude, and the other one is the period. So amplitude, let's start with that one. So again, amplitude is the distance from the center line to the peak or the trough or the crest. All right, so on my sketch, here's the center line. So my amplitude is that distance right there, or it could be that distance right there, or that distance right there. So the formula for that, so amplitude equals max minus min over 2. All right, so my maximum value is negative 0.31 minus negative 0.55. Divide that by 2, and I end up with 0.12 meters. Okay, so my amplitude is 0.12 meters. My period, so period is how long it takes for one cycle to complete. So length of one cycle. All right, so in your sketch it's good to draw either a max to max or min to min. So let's see if I can pick another color. I'll pick black, I guess. So your period is this length right here. All right, so that is your period. It's usually capital T for period. You might as well start using the right letter, because that's what you're going to use in the grade 12 course if you continue on. So again, we're just looking at how long did it take from one point to the other. If I go back to my sketch or Desmos, I'm looking at my x values. So 360 is the second min, minus 0, that's where I started. So therefore, my period is 360. Now it could be time on the x-axis, it could be height, it could be distance. You never know what it's going to be, but it doesn't really matter. You're just reading off your Desmos graph to measure that. All right, so there is, oops, that question completed, or the A and B part's done. Okay, flipping over then to the next page of the note. Now you'll see this is what happened up top. I thought I was being smart and giving you the graph to work with. I forgot to change this to radian or degrees. So this is in rads. So this graph is absolutely no good to us. So you can cross it out. All right. So I've pasted this on here just so we have something to talk about. All right. So rotate it, make it look like it semi-fits. All right. And then I guess I just got to group that together quickly here so I can move things around. So, oops. Back to my hand. All right. So, next part, C part says, determine max and min depths. All right, so that's easy when you have Desmos, because you are looking for, here's the top. This is where the propeller is going to be the highest, and this is where the propeller is going to be the lowest. So that's a straightforward question. Maximum depth. And I guess maximum depth in this case is the deepest point. So maximum depth will be negative 0.55 meters. And the minimum depth, or the most shallow point, will be the negative 0.31 meters. All right, so there is question C answered. Now moving on, the question down here, you can see I did a bit of a small typo. I did 3 seconds. Can you cross that out? You want to use degrees here, because I assumed that the x-axis was in time, but of course it's not. We're measuring the depth based on how far it's rotated. So that's what this is asking. So this one's saying, what's the depth of the tip after 50 degrees? So that means that we're looking for depth, and depth is h of t. So h of 50 equals, so we go back to our original equation, 0.12 sine of 50, because that's what's going to replace our t, plus 90 minus 0.43. So we're going to plug into the calculator 0.12 sine 50 plus 90, 140.43. So if you're going to use the script calculator, it looks you enter it exactly as it looks. For the rest of us, we're going to have to use calculator here. So with the calculator, we enter in exactly what's asked. So I start with 140 sine with this calculator, so I do 140 sine. Then I multiply it by 0.12 negative. Whoops, messed that one up. Try that again. 140 sine times 0.12 negative equals. Then we subtract off the 0.43 and we get 0.51. Okay, negative 0.51. So, whoops. See if I can get back to what I need. Here we go. So negative 0.51, and that is our answer. So therefore, at a rotation of 50 degrees, the depth is 0.51 meters. All right. Okay, moving on to the last page here. So I've already inserted the graph for us to take a look at. The first one is determine when the blade reaches a depth of, and you want to change that to negative 0.4. So with that one, I'm going to show you the steps. So we are just going to use our equation. So this time we want to know, we know what ht is. H of t equals negative 0.4. So therefore, negative 0.4 equals negative 0.12 sine t plus 90 minus 0.43. We need to solve for t, so that means we got to isolate. So using algebra, we're going to add 0.43 to both sides. So that'll end up with positive 0.03 equals negative 0.12 sine of t plus 90. Now we're going to divide by negative 0.12. So I'm going to need my calculator for that. So 0.03. So clear that. 0.03 divided by 0.12 negative. And I get negative 0.25. So negative 0.25 equals sine of t plus 90. Now we're looking for the angle, so that means we're going to do sine inverse here. So we're going to take sine inverse of both sides. So I'm going to move over a little bit here so I have some space. So my next step is going to be t plus 90, the angle, equals sine inverse of negative 0.25. So that means that t plus 90 equals, and if I go back to my calculator, I just have to take that answer and do sine inverse, and I get negative 14.5. So again, go back here, negative 14.5, and then we subtract 90 from both sides, and we get an answer of t equals negative 104.5 degrees. All right, so that's one of the positions. It's not the only position, but that's one of the positions. Okay, quickly to finish it off then, what would change in the graph if longer blades were used? So if we moved from small blades like this on my boat and I moved to bigger blades like that, what would change? Well, if this was my paint mark here, it would go from there all the way down to here. On this one then, on the bigger one, it's going to go all the way down here. So that means we're going to have a larger amplitude. So we're going to have a bigger amplitude. And what happens if the blades turn faster? If our blades turn faster, rotated faster, that means that from here to return all the way back, it would return faster. So it would return faster. Turn faster to start point. So that means that the time it took, it means we have a shorter period. Alright, so the period would be shorter. If you have any questions in class, let me know, and I'll clarify what I can in class. So good luck with this.